Now we're going to focus on some situations in today's activity based off our notes and our warm-up. So we're going to start with Tyler's walk. So I'm going to take a look at this graph on the right, and I'm going to do some observations before I start reading. And I'm going to notice that my x-axis is elapsed time in seconds, and my y-axis is distance from the ticket booth in meters. So this is going to help me kind of paint a picture of what I'm talking about. So Tyler was at the amusement park. He walked at a steady pace from the ticket booth to the bumper cars. The point on the graph shows his arrival at the bumper cars. What do the coordinates on the point tell us about the situation? So for this question here, what does this point, 40, 50, represent? So give that a try. You could always check your answer in the third video. Following this, we created a table for Tyler's walk, and this shows the value of time and distance. So complete this table and then plot the pair of the values on the grid. So what I want you to do here is I notice that 0 time and 0 distance. Time is 20, distance is 25. 30 seconds is 37.5 meters. 40 seconds is 50 meters. So what would 1 second be? What could you do to solve for 1 second? Okay, and then make sure you plot these points here, knowing that seconds is your x and meters is your y. So if I was going to plot this one here, 40, 50, I look at 40 and I go all the way up to 50 and I plot my point of where they meet. So please attempt this. For this right here, unit rate may be helpful. So think about how much 1 second would be and check your work in a moment. Now that you have found those answers and you plotted your points, we were able to determine that your distance was 1.25 meters in 1 second. So what does the point 0, 0 mean? What does this mean during this ticket booth time? Where is he standing at 0 seconds? Think about this. The second question, how far away from the ticket booth was Tyler after 1 second? And then the third question, what is the constant of proportionality? What do you notice is happening? For every 1 second, Tyler is traveling how many meters? Okay, and where do you see this on the graph? How does it become constant on the graph? So remember, you can pause whenever as we work through these problems to give yourself some time to solve them. This is not the answers, so I apologize for this. But what this is here is I want you to plot the points in the table on the coordinate plane. So take these pieces of information, x and y, and I want you to plot these points on this coordinate plane. And after you're done plotting, what do you notice about this graph that you created? Is it proportional? Is it not? What are the two key factors that make it proportional if it is? So if I go for this one, 216, my x, which is down here, is 2, and my y is 16, so I know this is 10. These are going up by 2s, so 12, 14, 16 is where I put this point right here at 216. So continue finishing the rest of this table. The last question deals with seagulls. So as we look at this seagulls, it tells me immediately that 4 seagulls ate 10 pounds of garbage. Assume this relationship is proportional, so that's going to be going up by the same amount each time. So plot a point that shows the number of seagulls and the amount of garbage. So plot this point, 4 seagulls, 10 pounds of garbage. Following, use a straight edge to draw a line to the point 0, 0. So take that point that you just put and draw a straight line going from here all the way to 0, 0. And finally, plot the point 1k on the line. What is the value of k? What does the value of k tell you about the context? So k, we're not sure yet, but we could figure this out. If I was going to look at this graph in line that I just made, and I go to 1 for my x, if I follow it till I hit that line, what do you think k would equal? And maybe you could find the unit rate. If 4 seagulls ate 10 pounds, what would 1 seagull eat? How many pounds would that be? So think about some ways to determine what 1 seagull would mean.